Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Technology. Now we are going to see about the hardware virtualization in cloud computing and its applications. First one, hardware virtualization. It allows the multiple OS on the single physical machine. It is implemented using the hypervisor, that is virtual machines. Um, and then it abstracts and shares the physical hardware among the virtual machine, and it enhances the resource utilization, isolation, and the scalability. Next one, we have the problem statement, and the cloud service provider need to host a multiple customer application on one physical machines. Each customer requires a separate operating system with the strong isolation and the efficient resource sharing. The solution will be that hardware virtualizations. We go with that DT based solution. So we have a 5 stages. First one will be the empathize. In empathize, the multiple customers, key separate operating system and security performances. The second stage will be the define stage. Here we have the single server and then multiple OS isolations and the resource sharing. And then third stage will be the ideate stage. In ideate stage, we found that virtual machines, hypervisor, and then hardware abstractions. Fourth one will be the prototype. In prototype, we found that the virtual CPU, virtual memory, and the virtual input output devices. Final stage will be the testing. The testing, here we have the isolation, efficiency, performance, and the scalability. The components of the hardware virtualization. Here we have three components. First one is CPU virtualization, second one memory virtualization, third one input output device virtualization. The storage and the network devices are virtualized as a part of input output virtualization. It's supported by the hardware features in the modern processors. Next one, CPU virtualizations. It enables a multiple virtual machines to share the one physical CPU. It provides each virtual machines with the virtual CPUs. The hypervisor manages the virtual CPU execution and scheduling. It maintains the isolation among the guest OS. Next one will be the challenges of the CPU virtualizations. Here they're handling the privileged instructions and maintaining the performance while ensuring the isolation, and then context switching between the multiple virtual machines and the efficient scheduling of the virtual CPUs. Here we have the techniques of the CPU virtualization, that is trap and emulate, binary translation, para virtualization, hardware assisted virtualizations. Next one, hardware assisted CPU virtualizations. The modern CPUs provide the virtualization support, that is Intel VTX and AMD V. It introduces the new CPU modes for the guest OS execution. Here it reduces the overhead of instruction trapping, and it improves the performance and the security. Next one, the memory virtualization. It gives the virtual machine the illusion of the dedicated memory. The guest OS uses the virtual addresses. Hypervisor maps the guest memory to the physical memory, and it ensures the isolation and the efficient memory sharing. Next one, memory virtualization, that is address mapping. Here we have three addresses. That is guest virtual addresses, guest physical addresses, and the host physical addresses. Here the hypervisor manages the multi-level address translations. Next one, memory virtualization technique. Here we have that shadow page tables, nested page tables, or the extended page tables, and then memory ballooning, and then transparent page sharing. Hardware assisted memory virtualization. It is supported by the Intel EPT and AMD RVI or NPT. It reduces the hypervisor interventions. Here we have the faster memory accesses, but the lower CPU overhead, better scalability for the large virtual machines. And then input output device virtualizations. Here it allows the virtual machines to share the physical devices. Devices include the disk, network, USB, and the GPU. This hypervisor mediates access to a hardware. It ensures the security and then isolations. Input output virtualization technique. Here we have the device emulation, para virtualized input output, and then direct device assignment, and then SRIOV, that is single root input output virtualizations. The hardware assisted input output virtualization, it enables the safe DMA access, direct device access by the virtual machine, and used in the high performance networking and the storages. Here we have that assessment questions. In the first question will be the guest OS is modified to communicate directly with the hypervisor, it reducing the overhead and improving the performances. Here, which virtualization technique is used? So the answer will be the para virtualizations. Thank you.